Okay, guys. So just open the Jupyter notebook, please. Okay, just open. So just remember this snippet of codes. Here we have done the distribution of the random variable x for binomial, that is the binomial distribution for random variable x. Okay, so you know RVS stands for random variable for SciPy package. Okay, so random variable sample. Okay, defines the size. Okay, so you are getting all such things. Let's look at the output. When you print this x dot probability mass function 3, okay, so that means for the probability x equal to 3, that is what I want to print. Okay, then cumulative density function, that is p of x less than equal to 4. Okay, and this is mean, you know, variance. This is expected mean or long-term mean, long-term average. Okay, then standard deviation, then RVS. Okay, look, when you don't spend any numeric value to this RVS method, then what happens? It will just give you the a single value 2, but when you pass that you want uh, an array of 10 values, it will give you this 3 1 2 0 2 5 3 1 4 1 10 such samples. Okay, 10 random samples from the random variable x. Okay, if you want to draw these values for Poisson distribution, then you have to pass these values. And then this is the range 100 to 200.5 is the step that, and in this way you can draw the value. Okay, 150 is the mean. Look, if you look at the plot, your mean lies between 140 and 60, that is 150. Okay, understood? This is Poisson distribution. Poisson distribution. Okay, now look, from SciPy import stats, we can use this NP. N is the number of samples. Okay, and 0.2 is the probability of success. So I want all the methods to be listed for this binomial random variable x. So if you just use help on this, if you just call help method and pass this random variable x, you will get what are the methods present here. Okay, this is percent point function, which will give the which is the inverse of CDF and give the x value itself. Okay, this is self function, that is 1 minus CDF. Okay, survival function, sorry, 1 minus CDF, and these are the functions you can search on internet and do such things. It's up to you. Now come to this part. Okay, so if I use Poisson distribution, then we can get a probability mass function. Okay, for the value 3. Okay, and if I want to if you want to get a random sample from this y, Okay, from this Poisson random variable, for this Poisson random variable y, then it will give you 5. Okay, it will vary. Okay, because this is random, you will not get the same thing. Okay, look, import math from SciPy, import stats. Okay, this is normal distribution. Okay, so this is your probability density function, because for normal distribution we need to consider continuous variables. Okay, so f of 3, the probability density at 3. Okay, so and CDF2 f of 2, which is also p of probability of y less than 2. Okay, and get a random sample from A. Okay, now look at, we have used here random method, which is present in random module. Okay, and just look at the range 1000. Okay, number of beans is 50. There counts and beans will be given, that is the np dot histogram x beans equal to your number of beans. Okay, so beans equal to beans, that is for row minus 1 plus beans 1 minus beans 0 by 2. Okay, that is the width. Okay, now this is your probability counts by float of counts dot sum. Total sum of probabilities is equal to 1. Okay, so when you draw bar, you have to pass these beans, the total beans. Okay, probabilities, and since your sum of probability is 1.0 by number of beans. Okay, so when you draw, you will find this. Now look at this. If you want to draw histogram, okay, you can do that also. Okay, these are some way of doing plots. Okay, now look at the definitions. Look, given 10 trials for coin toss generate 10 data points. Okay, so if you use random not binomial, you have to specify n equal to 10, p equal to 0.5, size equal to 10. Okay, and if you print them, if you print the x, we'll get this. Okay. So if you want to print, if you want to plot, you can do that as well. Okay. Look at this heading. The main difference is that normal distribution is continuous, whereas binomial is discrete. But if there are enough data points, it will be quite similar to normal distribution with certain log and scale. Log mean or average, and scale means standard deviation. Okay. Look, this log 50, scale 5. Okay. You can use listened for better understanding. Okay. Just wait. I will run everything. Look. Understood? Now come to this. Poisson distribution is a discrete distribution. Okay. It estimates how many times an event can happen in a specified time. Okay. If someone eats twice a day, what is the probability he will eat thrice? Suppose there is a jam. Okay. Jam happen on a road. Okay. Every day for 10 minutes, but what is the probability that the jam will happen for 12 minutes on that road? Okay, it is then we have to use Poisson distribution, where it has two parameters. One is LAM, stands for lambda, which implies rate or known number of occurrences. Okay, in this case, example 2 for our problem, twice a day. Okay, so and it returns out, the output is size, the shape of the returned array. Okay, so generate a random 1 cross 10 distribution for occurrence 2. Lambda is equal to 2 and size is your 10. If you don't specify size, it will return only one value. Okay, when you want 10 samples for this for the occurrence of 2, then it will return 10 samples. Okay, so look, now look at this. If you want 5,000, okay, I have drawn distribution plot from the Seaborn, which is present in Seaborn package. Okay, just look, then it happens. Okay, Now look at this normal distribution. I have made here histogram to false. I don't want histogram. I want curve. Okay. So look at the difference between binomial and Poisson distribution. Okay, binomial distribution is for discrete trials, whereas Poisson distribution is for continuous trial. Okay. Because look, 12 minutes, 10 minutes. Okay, these are the continuous trial. Okay. So, but for very large n and near zero, p binomial with distribution is near identical to Poisson distribution, such that n into p is nearly equal to lambda. Okay, that is the rate of occurrences. Look, rate or known number of occurrences, that is lambda. Okay. Now look, used to describe probability where every event has equal chances of occurring. Okay, generation of random numbers. Okay, default lower bound is your default 0.0, upper bound is 1.0. Okay. Look at this 2 cross 3 uniform distribution sample. This is the uniform method. You have to pass the size. This 2 rows and 3 columns. Okay, for a matrix of 2 rows and 3 columns, all the values will be generated. Now, if you want to use the distribution plot for this size equal to 1000, okay, that is only x values are mentioned. Okay, not any row column matrix. Then this is the figure. Okay, now this is your uniform distribution plotting. Okay, now what is the exponential distribution? It is used for describing time till next event, example failure or success, etc. It has 2 parameters, scale, inverse of rate. Okay. And it will return the shape of the returned array. That okay. How many time? How much? Sorry. How much time? How much time? But the next event will take to happen. Okay, uh, that is why we have to draw exponential distribution. Okay. We have to draw the distribution plot for size equal to 1000. Okay, now look. Poisson distribution deals with the number of occurrences of an event in a time period, whereas exponential distribution deals with the time between these events. Okay. That means if your first, suppose twice a day you eat, that means first time you eat and second time you eat. Okay, so this is the number of occurrences. So first time eating is one event and the second time eating is second event. So what so exponential distribution deals with the time between this first and second event. Okay, so if you eat 10 times a day, so it will just compute, it will just consider the exponential distribution, just consider the interval between each such consecutive events. Okay, now look at this Pareto's law. Just wait for 2 minutes. Look at this Pareto law, where 20% factors cause 80% outcomes. Okay. This is your shape 2. Now this is multinomial distribution. Look at the multinomial distribution. It is a generalization of binomial. Okay. So when suppose blood type of a population dice roll outcome, okay, where the number of outcomes is more than 2, okay, because in case of binomial we have seen the scenarios must be only one of 2, okay. So it has 3 parameters, number of possible outcomes, like for example 6 for dice roll, okay, probability values, list of probabilities of outcomes, okay, size, it is returned, the shape of the returned array, okay. Now this is how we have to define. We have to pass these probability values. Look, in case of binomial distribution, we just pass the probability of success. But here you have to pass the list of probability values for each outcome. Okay, so p-val is equal to these values are passed in as a list, and this is the number of trusts, that is 6. Okay. Okay. Now come to this part. Look, as the generalization of binomial distribution, their visual representation and similarity of normal distribution is same as that of multiple binomial distribution. Okay. I will ask one question. Okay. Just explain me what does this output mean? Who will answer me? Shima, just answer me. What do you understand by this code? Then I can understand that you all have understood. Tell me, Shima, are you there?
Yes, ma'am.
So tell me, this is random dot multinomial. Okay, that is multinomial distribution. N is your
Yes,
side.
ma'am.
Okay, all the outcomes is that is if you have 1, 2, 3, 4, 5, 6, 4, 6 in
Yes,
that,
ma'am.
is
Here
from
are
the
six outcomes
definite
random, which
1
are
by 6,
comes
1 by 6.
randomly.
Okay. So tell me what does this output mean?
Ma'am, here there are six outputs which comes randomly from 1 to 6 number.
No, just wait. I'm giving you all 5 minutes. I want answer from everyone must try.
Ma'am, here there are six probabilities of outcomes. Ma'am, which is between 1 to 6 number. So here randomly the probabilities are 1, 0, 2, 1,
No,
1,
no,
1.
no, no. I will receive answers from you all after 5 minutes. Just think. Punita, what is your answer? Ujjal, what is your answer?
Ma'am, this output 102111. Ma'am, as we are
Why did you get this output? It will change. Okay.
yes,
If you
ma'am.
run for the next time, you will get a different one.
Ma'am, as we are using multinomial, so for each value of p-ones, it is finding the output.
No. Look.
Ma'am, we have. Shall I try?
Tell.
Hello.
Yes, tell me.
Ma'am, here I have a task of choosing this what we call as from a list of 6 of probability values.
Look, I want why did you get 102111? What does it mean? This one means what?
Ma'am, the outcome which we get, if 1/6 comes for 1 times, then it is 1.
Just tell me, if you add all these, what will you get? 1 plus 0 plus 2 plus 1 plus 1 plus 1.
6.
Yes. This is a hint. Now just think. In a dice, there are 6 outputs. 1, 2, 3, 4, 5, 6. These are the probabilities. Each one is getting equal chance to occur. Okay. So what is this mean? What does this mean?
Ma'am, as it is random, so 1/6 may come for 1 times.
You all have not understood anything, I think so. Have you all understood the previous codes?
Ma'am, these are number of possible outcomes for a dice roll.
How can you say? Possible outcomes. 1, 2, 3, 4, 5, 6. 6 will happen. Okay, if each one is given equal chance. Okay, so when each one is given equal chance, so each output will happen. Each output can occur because they are equally given because they are given equal chances to happen. So I am not biased. It is random sample. So 2 can come out or 3 can come out. I am asking why did this 1022 why this 102111 imply. Okay, if you throw your dice and get 1, okay, understood or not understood? Understood? I am asking you all. If you throw your dice, you have got 1, you can get 2, you can get 3. Okay, so out of 6 trials, look, the total is 6. Okay, out of 6 trials, you are getting 1 only single time, but you are not getting 2. That is why it is mentioned 0 as 0. You are getting 3 2 times. Okay, you are getting 3 2 times. That is twice. You are getting twice. What are you getting twice? 3. Output 3 is obtained twice out of 6 trials. Okay, then 4, output 4 happens. Output 4 happens once. 5 and 6 also happens for once respectively. Okay, but you have not got in this 6 trials your output 2, that is second output. Okay, understood? Ujjal, have you understood?
Yes, ma'am.
So are you getting 2 here?
No, means for 2 we are not getting. For the output of 3 we are getting twice, ma'am.
Yes,
For output of 2 we are not getting anything.
exactly. Look, this is your number of trials, na? And this is your probability values. For given equal values for each one of the outputs. Okay. When you are rolling a dice, you will get six, either 1, 2, 3, 4, 5, or 6. Okay, that is, you will get one of the 6 outputs. Okay, so everyone is given equal chance to happen. So this array, this list of values will in the output will imply that number of occurrences for each output in a given number of trials. So if you add them, it will actually sum up to the total number of trials, that is n equal to 6. Okay. So the distribution of outcomes, that is the occurrence of outcomes for the trials. Okay, the number of outcomes for the trials. Okay, the occurrence of the trials. Okay, sorry, the occurrence of the outcomes corresponding to the trials. Okay, the occurrence of the outcome corresponding to the trials. Okay, that is your output. I am repeating again, the number of occurrences of the outcome corresponding to the trials, corresponding to the total trials, is the output. Understood? If I
Yes, ma'am.
repeat it, look, now what happened? 1 happens, the output 1 comes,
Change digit.
and the output 2 comes once, but 3 and 4 has not come. Okay, have not come here. That is 3 and 4. You have not got 3 and 4 output in any one of these 6 trials. Okay, you are you have got 5 and 6 twice out of 6 trials respectively. Okay.
Yes, ma'am.
Okay. Now look, this is the normal distribution. This is also called the Gaussian distribution. Okay. After the German mathematician Friedrich Gauss. Okay. It fits the probability distribution of many events. IQ scores, heartbeat. Okay. All are continuous variables. So this is your random dot normal method to get a normal data distribution. Okay. 3 parameters. Slope is your mean where the peak of the bell exists. Standard deviation, how flat the graph distributions should be. And the shape of the returned array is your output. So this is how you have to generate normal distribution. Look, by default, if you don't specify log and scale, that is mean and standard deviation, the mean is your what? What is the mean of a normal distribution? Tell me. If you don't specify, otherwise. Give me answer.
0.
Yes. How much time you all guys take? And what is the standard deviation?
1.
Yes. And skew?
Skewness is 0. Right?
Yes. And kurtosis?
Toss is less than 3.
No. Equal to 3.
Equal to 3. Yeah.
Greater than 3 is rightly skewed. Less than 3 left skewed. Okay.
Yes.
Keep these things in your mind. Okay. So look. If you want to if you want to generate values, okay, for different mean and standard deviation, you have to specify them within the normal method. Okay. And now if you want to draw plot, okay, look at 0, this is mean, and the other one is your standard deviation here. It is for the size 1000. Okay, that is 1000 data points. For 1000 data points, I am drawing this density curve, okay, for normal distribution. It means 0, and this is my 1 sigma standard deviation. Okay. I don't want to draw the corresponding histogram, so I have said here I have said the parameter hist equal to false. Okay. Okay. Now we have to learn something. So I think we are done up to that, na? In the last session. So
Yes,
you
ma'am.
have to take down these things today. So just take down these things and I will explain. Just wait for 2 minutes. Take down. Done? Done?
Yes, ma'am.
Vidisha? Punita? Shima?
Yes, ma'am.
Okay. So have you all understood? Look, in this in the second row, 10, 20, 30, 40, 50, 60, 70, 80 present, okay? So look, there is a gap between 80 and 60, and there is no gap between 50 and 50. Okay. So 10, 20, 30, 40, 50, 50, 60, 80. Understood? So in the 0th and first row, there is no as such, there is no as such uneven differences, but here the differences are even between the consecutive values. Okay, that is the uniform. Okay, but here look, 50 minus 50, there is no difference, and here 80 minus 60, the difference is a little bit high compared to the difference exists between the other values, between the other consecutive values. Okay, look, 20 minus 10 is 10, 30 minus 20 10, 80 minus 60, whereas 80 minus 60 is equal to 20. So that's why a little bit deviation takes place here. Okay, that is, it is not completely normal. Okay.
Ma'am, what is NaN?
Not a number. Look at the values 1 2 3 4 5 6 7, 1 2 3 4 5 6 7, 1 2 3 4 5 6 7 8. So in the second row I have 8 columns, that is 8 values, but I have to make a match now for the corresponding rows, so that becomes not a number because I have not assigned any number. Understood? Look at this data val. Understood?
Yes, ma'am.
Now come to this. Take down this. This is kurtosis. Okay. The negative sign with magnitude just tells that this is the left, that is the obviously your that is not your normal kurtosis distribution. Okay, so if it is negative kurtosis, then you will tell it just wait. Yes. Yes, I was there. Yes, yes. So this is your uh, data frame, okay? And look at this. Um, that is your courtesy is negative, so with magnitude that is less than 3, so you will say that is platykurtic type, that is flattened uh, uh, data. In fact, this first row has such things, uh, and in the zeroth row, this is almost considerable. Okay, this is almost close to mesokurtic, although it is showing by result platykurtic one. But the first row, if you draw the data curve for data values for the first row, then it will just give you a platykurtic distribution. That is that is flat distribution, less pickedness. Okay, or presence of uh, outliers is less. Okay, or less number of high range values. Okay. Have you all done this?
Yes, ma'am.
Yes, ma'am.
Okay. So now take down this. This is Chebyshev's theorem. Just take down.
Can you please scroll down? Can you please scroll down? Ma'am. Ma'am.
Yes, tell me.
Ma'am, which sign is used here? Exclamatory sign. Ma'am, in STR probes. And after that, ma'am, in theory, probability less than. Ma'am, before in theory. Ma'am, which sign is used?
This is.
Ma'am, no. Before that.
This is plus.
Ma'am, here, before in theory.
Before
in theory.
Yes, before. This is pipeline operator.
Ma'am, which operator?
Pipeline operator. Pipeline sign. Look, use when you press on your keyboard, when you press forward slash, if you press shift, then you can enter pipeline operator.
Okay. Can you please scroll down? Ma'am, can you please scroll down?
Tell, what are you telling?
Can you please scroll down?
Have you run it? Have you got this output?
Yes, ma'am.
Okay. Have you understood? So up to 1.5 standard deviations. This is my observations.
Ma'am,
Okay.
please show last line. Yes, ma'am.
So understood. You all have got you all have gone through the Chebyshev's theorem so far. I remember, so I don't want to repeat. You know that is your these deviations from the mean just suggest the maximum and minimum number of observations that you have got, that you can get. Okay. Remember, what is Chebyshev's theorem? Just tell me. I want answer. Ujjal, what is Chebyshev's theorem? I have already covered now. Tell me, what is Chebyshev's theorem? Ujjwal, are you there?
Yes, yes, ma'am.
So just tell me.
Ma'am,
Theorem.
Chebyshev's rule is used in the measure of dispersion, like in order to measure standard deviation.
This is. Chebyshev's theorem estimates the minimum proportion of observations that fall within a specified number of standard deviations from the mean. What is the difference between normal and Chebyshev's? 68% and 95%, 99%. These are the exact data distribution that takes place in case of normal distribution. But here we cannot say in such a way because here we deal with approximations. Here, look, minimum number of at least your what is the percentage? At least you can say. If it is your probability is 0.082 at 1.5, you can say at least 82% observations fall within 1.5 standard deviations from the mean, and at most, okay, at most your at this point, if it is your 82, so you can say the rest, that is if 82% falls with the at least for 82% of observations fall within 1.5 standard deviations from the mean, then at most 18% observations fall outside or greater than 1.5 standard deviations from the mean. Look at these deviations. Okay, this is at most 18%. Okay, and this is at least 82%. So here we are talking about at least and at most observations that falls within or greater than a particular, a specific standard deviation from the mean. Okay, we deal with approximations. This is the main difference between Chebyshev's theorem distribution and normal distribution. So here, look, this is your 1.5 standard deviation. Okay, so minimum number of proportions that fall within this. That is at least the number, at least what percentage of proportions fall within these 1.5 standard deviations from the mean. That is that is your threshold sigma. Okay, understood? Ujjwal understood and everyone else understood?
Yes, ma'am.
Just go through that one.
Okay, ma'am.
Okay. Now just take down these. I will give you this .csv file. Okay. This is how to find correlation and drawing the correlation between two variables. Okay. So using how to find out the correlation coefficient using Pearson and Spearman method. Okay. So just take down these. Then I will give you the Excel file. Okay. Just do fast. Take down. I will also have to complete today jet test, one sample t test, two sample t test, independent two sample t test, and that is that one, and also paired sample t test. Okay. In the next session, I will deal with chi-square, ANOVA, and non-parametric test, and basic things of machine learning. And after that, we will start linear regression. Okay, logistic regression, these things. No, okay, I will take machine learning along with clustering, and then I will start linear regression and logistic. That is regression and classification part. Okay, after that. Then decision making, support vector machine, random forest. And then Naive theorem, market basket analysis. Take down, take down. Be fast.
Ma'am. Ma'am.
Yes, tell me.
Can you scroll down?
Ma'am, please share file.
You all have done now?
Yes, ma'am.
Okay.
I haven't received the file.
I've just sent. Have you all got the file? Have you all run the snippet of code? Have you all run this snippet of code?
Yes, ma'am.
Have you got the same output?
Yes, ma'am.
What did you understand? Okay, I'm giving you all 2 minutes. Just explain me. Tell me. Ujjwal, tell me, what did you understand?
Ma'am, here two values are being compared, and as we are considering a Spearman correlation, so it takes monotonically related values. So as the x will increase, the value of y will also increase.
Look, this is your Pearson R value, okay? And this is the P value. Look, this is 0.0006. If you set your alpha 0.05, so your 0.0006 is very much less than 0.05. Or even if you set your alpha 0.01, that is so the p value which you have obtained is very less than that. So you can say yes, there is a significant correlation exists between this working experience and bugs. Okay. This is the value of the correlation coefficient, but how can you say that the value is significant or not? This minus 0.69 says that is negatively correlated for 69%. Okay. But whether this correlation is significant or not, that will be determined by the p value. Okay. And if you look at the Spearman R result, so this the correlation rho equal to minus 1.0 here. Okay, that is perfectly negative. Okay, correlated for monotonous. Okay, monotonic relationship. You know, we have we did these things. I just want to remember you. Okay, I'm showing again something. Look at the figure. Remember, strong negative monotonic relationship, strong positive monotonic relationship, strong quadratic. Okay. And look, these are the values. This is for Pearson's. And this is Pearson's and Spearman. Okay. Remember? Now look at this figure. Okay, this is how I have drawn the given working experience and code bugs are drawn. I have given text 1, text 2. You have to set your x level and y level accordingly. Okay, accordingly bugs and working experience. Okay. Now just look. I have explained this hypothesis. Look, correlation minus 1.0 for Spearman. The correlation coefficient rho is minus 1.0. Now p value is 0.0, so it is less than 0.01 or 0.05, obviously. So it is also telling that yes, they are significantly correlated, and the value is negative. -1 suggests negative correlation, okay, and one suggests perfectly negative, okay. And significantly correlated or not can be decided by p value, which needs to be checked against the given alpha. If it is if your p value is less than, if your p value is less than the alpha given, then then alternative hypothesis is true. Then it supports enough evidence to say that we have to reject the null hypothesis, okay. And if p value is greater than the given alpha, then we will say then it is will just suggest you that there is enough support or evidences that the null hypothesis, that is, there will be no correlation between working experiments and bugs if p value is greater than alpha, okay. If your alpha is 0.05 or 0.01, okay, in that case you will say we fail to reject null hypothesis, okay. So now come to this part, z-test statistic. Take down these things. Guys, you all take down these things, z-test, t-test, everything. I think today, if you take down these things, that will be good. I will give explanation in the next session. Just take down these things.
Ma'am, can you please share this CSV file?
I will share that later. Now you just take down. Have you finished?
Yes, ma'am.
Okay. Now take this for 46th line. Have you taken down this? Have you taken down this also?
No, ma'am.
Okay, take down this first.
Yes, ma'am, done.
Take down the 47th line.
Yes, ma'am, done.
Have you taken this one? Have you taken down this one?
No, ma'am.
No, ma'am. Just take down. Done or not done?
Yes, ma'am, done.
Take down this one. Have you all done this? Have you all jotted down this?
No, ma'am.
Done or not done?
I'm not done.
Done or not done?
Done.
Punita, where are you?
Yes, ma'am, done.
Shima, done? Bidisha, done?
Yes, ma'am, done.
Okay. Take this one. Take down this one. Done. Up to what part? Up to group by part done.
Ma'am, done.
Take down the remaining part. Done? Shima, you are at which line?
From SkyPy.stat. Import Bartlett.
Okay. Punita, you are at which line? Punita?
I'm about to finish. Ma'am, about to finish.
Okay. Vidisha, you are at which line? Vidisha is not responding. Okay. Ujjal, you are at which line? Ujjal, you are at which line?
I'm that ANOVA line. Commented line, ANOVA.
Okay. Punita, you are at which line?
Ma'am, ANOVA table is equal to ANOVA.
Shima, you are at which line?
Last line.
Ujjal, you are? Ujjal, you are at which line?
Ma'am, sample t-test, commented line.
Okay.
Can you please show the last line?
Done, everybody?
No, ma'am.
Done.
No, ma'am.
Okay. You are at which line?
Ma'am, last line.
Okay. This is do it for rest 9 groups. Okay, REST. Okay.
Yes, ma'am, done.
Okay. That's it for today. Anish, are you there?